This is Unit 3 Triangles, Lesson 3.1, Triangle Sum and Exterior Angles. You should have your notes in front of you. Don't forget to get the location and the date and time of your video. Come over here to the review section. I'd like you to take the time to graph the line. Pause the video, graph the line, then check. Students, welcome back. Let's see how we did here. Your goal is to get y all by itself. That's your ambition. So step 1, we want to take 25 over. You want to get y by itself again. So we're going to get rid of the double date, which is the 3x. Now we're going to get rid of the negative 6. So there goes the date. She's going to come over here and gossip to everybody. 3 over 6, that's 1/2. Double negative makes a positive. So we have y equals negative 1/2 plus 4. That means our line must go down from left to right. So we're going to start at positive 4. Down 1 over 2. I could also go up 1 and over 2 this way. And you have your line. Hopefully graphing of lines is getting easier and easier for you. Now we're going to be graduating from lines today into our first shape. We're going to start talking about triangles, the most basic and most important of shapes in all of geometry. By the time you're done with today's lesson, you should be familiar with all of these terms: acute, right, and obtuse triangles, scaling, isosceles, and equilateral triangles, equiangular, the concept of triangle sum, and remote angles. Triangles can be classified by two things. They can be classified by their angles or by their sides. They can be classified by their angles or by their sides. For angles, we have acute triangles, actually let's put them in this order. We went acute, obtuse, and equiangular. Down here you're going to put right. Okay, an acute triangle is any triangle with all three angles less than 90. That's acute. Obtuse is where you have a triangle with one obtuse angle. So you have a triangle with one obtuse angle. That means greater than 90. Equiangular is where all the angles are equal. And of course, a right triangle is where you have one angle. That is 90 degrees exactly. Obtuse, acute, and equiangular angles, we call those oblique, meaning non-right. Classifying triangles by their sides. You have scaling, scaling means all three sides are different. So watch the hatch marks. 1, 2, 3. Notice none of them match. That means it's scaling. Isosceles, two sides are equal. I turned it sideways on purpose. You guys are used to seeing isosceles triangles upright, but I wanted you to see that isosceles triangles can be rotated. And of course, equilateral means all three sides are equal. So there's the 7 different classifications of angles. So for this one, we're going to classify it by its sides and by its angles. By its angles and by its sides. So angles first. Let's look at the angles. We have a 23, a 69, and a 90. So immediately I know that this is a right triangle. Sides. I take a look at the sides. None of them are equal. So this is a right scaling triangle. It's a right scaling triangle. Here below, I'm going to draw an isosceles right triangle. An isosceles right triangle. So I want a triangle with a right angle with two sides equal. I'm going to start with the right angle. And then I want two equal sides. They must go around the right angle. And I'm going to close this up this way. And that is an isosceles right triangle. Number 3 says I'm going to draw a triangle ABC, which is isosceles, two congruent sides, the vertex of B. So I want my congruent sides to be AB and BC. Notice how B is repeated? That means B is what's called the vertex. It's the hinge between the two equal sides. I'm going to make my equal sides that. B is my hinge, so B goes between the two equal sides. Let's see if we matched it up. It says that we should have AB congruent to BC and two sides equal, which we do. So now you're going to pause the video and finish this page, restart the video when you are done. Welcome back. We want to classify triangles by both their sides, which we need these words right here. That's classifying by their sides. And we want to classify by their angles, which is right here. So taking a look at number 1, all of them are different, so that makes it scaling. And the angles are all less than 90, so this is a scaling acute triangle. The one on the right, taking a look at the sides. Notice we have 2 sides equal, so this makes this isosceles. Taking a look at the angles, you have a right, so it's an isosceles right triangle. Sides again, notice nothing's equal, so I'm going to write scaling. And we have 1 right angle, so this is a scaling right triangle again. Taking a look at the sides, notice all 3 are equal, so this is equilateral. Equiangular. It's equilateral and equiangular, which is true every single time you have an equilateral or an equiangular triangle. Now that we've gone through triangle classifications, we're going to go through the most basic concepts of triangles. The first most basic concept, notice here, here's a triangle with 1, 2, and 3. And if we were to slice these corners off and rotate them around with the vertexes as the hinge right there, slice 1 off, we're going to put it there. Slice 2 off, rotate it around like a cookie slice, and slice 3 off. If you notice you put all 3 of them together, I'd like you to physically sweep this from here. Put your pencil where that dot is. Actually, put your pencil on the paper, please. Sweep. This is a physical demonstration of how triangles add up to 180 in all triangles. So in Euclidean geometry, or geometry on a flat surface, triangles always add up to 180. I'm going to color code it here, so 1 angle plus the other angle plus the 3rd angle always add up to 180 in geometry. Euclidean geometry. We'll be talking about there's a different kind of geometry in class. So in a right triangle, if things always add up to 180 and you have a 90-degree angle, that means these 2 angles have to add up to 90. So in a right triangle, the acute angles are always going to be complementary, which means sum 90 degrees. So let's do one problem together. When you work through these problems, again, talk about things before you talk about angles. I'm going to use 3 different colors. I recommend you do the same. So I'm going to sweep all 3 angles. I have a blue angle, and I have a green angle. I'm doing a red angle. And what do I know about these angles? They all 3 add up to 180. Notice I did not immediately go for the algebra. I talked about things before you talk about algebra. We think in terms of things such as angles and segments. Now we're going to go back, circle, plug, chug. We have the blue angle, blue equation, green angle, solve for x simultaneously as I do and double check your work. We're going to start by collecting like terms. If you checked your work, you should have gotten x equals 42. But wait, there's more, because this is geometry class. This is not algebra class, and the world doesn't end with solving for x. So you come back up here, and we're going to put 42 everywhere where it belongs. So this is going to be 3 times 42 plus 4. Backtrack, students. Maybe you caught my error before I did, but I dropped a 1 there. We are dividing not by 4, but by 14. And the reason I was able to catch that is the second I went to put this up here, realizing that'd be way more than 180, you can catch yourself. So basic math facts help you do your math correctly. So we're going to do 168 divided by 14. Now I'm being really careful, double checking my math. X equals 12. Let's see if that works. Coming back up here. Yeah. 3 times 12 plus 4, that's going to be 36 plus 4, that equals 40. So this angle is 40 degrees. This is going to be 3 times 12 plus 9, that's 36 plus 9. It's going to be 45 degrees. Up here we're going to do 8 times 12 minus 1, that's going to be 96 minus 1, that's 95. And if we add all of these up, they should add up to 180. So 95, 45, 40. Here's our check. And yes, it is 180. Another problem, taking a look here, what you should have immediately noticed is that we have armpits of the Z going on. And we are told that the measure of angle 5 is 70. And the measure of angle 4 is 45. And our goal is to find all possible angles. Because we have parallel lines, we need to watch out for armpits of the Z. So you still have to remember everything you learned about parallel lines. It's going to come into play. So I'm going to take that 45 and pull it down here. Take that 70 and pull it down here. And now I know triangles add up to 180. So again, I have angle plus angle plus angle equals 180. So it's going to be 45 plus 70 plus x equals 180. We're going to solve for x. Combine like terms. And we find that x equals 65. Now there's a continued check. We can go like this and double check that that adds up to 180 up here, which it does. So you can easily see how everything fits together knowing that triangles add up to 180. Now what I'd like you to do here is I want you to find all possible angles. And not only do I want you to find this angle here, but notice the dotted line. I want you to take the time to sweep the dotted line, and then I want you to find this angle on the outside as well, right there. Find all the angles in the diagram. Go. Okay, welcome back. Let's see how you did. You had 40 and 80, that's 120. Take it away from 180, you should have gotten 60 here, which means this angle on the outside is 120. Taking a look at this one, let's do 35 and 75. We're going to add them up. And that's 110. Take it away from 180. That means this angle here is going to be 70. And when you sweep, you should have gotten 110. Now notice a pattern here. Take a look at this pattern. This angle that you found on the outside is the same as these two angles that are far away on the inside. Did you notice that pattern? That is true of all triangles. That's called an exterior angle. These are called the remote interior angles. Remote meaning far away. That's a pattern that's true of all triangles. Let's talk a little bit more about exterior angles. Exterior angles, they kind of look like a pinwheel. That's why I have a pinwheel here. To find them, we're going to extend each side and go clockwise. So let me show you. Extend with me. Extend. And we're going to go around the clock to the right. Extend. Extend. Clockwise. Those are exterior angles. They're the angles when you extend the sides. And we went clockwise. All three of those are exterior angles. Let's try counterclockwise. We're going to go the other way now. So ready, take this and go down and around. I want you to see that you can go both directions, counterclockwise. So what we learned from our prior activity is that when you have an exterior angle, like angle 4, it always is the sum of what's called the remote interior angles. Remote means far away, interior means inside. So here we have an exterior angle. That exterior angle equals the sum of what's called the remote, far away, interior angles. So the remote interior angles add up to that one exterior angle. Let's use this as an illustration. For example, here's angle 6. Angle 6 is an exterior angle. Its remote interior angles, so remote far away but still inside the triangle, is going to be angles 3 and 2. So angle 6 is going to equal the sum of angles 3 and angle 2. Sweep angle 9. Angle 9 is also exterior, so you ask yourself what's far away but inside the triangle? Inside. And that's also angle 3 and angle 2. Let's try another one. I'd like you to sweep angle 4. Notice 3 can't be in there anymore because it's no longer remote. It's adjacent. So ask yourself which two angles are far away but still inside the triangle from 4. And that's going to be angles 1 and 2. Let's do angle 7. Sweep angle 7. Which two angles are far away but still inside the triangle? That's going to be angles 1 and 2. I'd like you to stop the video and do these two, and then restart when you're done. Alrighty, students, let's see how you did here. Angle 5. Angle 5 is out here, and the remote interior angles right here, you should have marked 3 and 1. Angle 1 and angle 3 are the remote interior angles and add up to 5. There we have angle 8. And the remote interior angles of angle 8 is again angles 1 and 3. Yet a last problem, you were to find all the measures in the diagram. So we know that this exterior angle equals the sum of the remote interior angles. So I'm going to do this. 115 is over here. I don't know the blue, but we have the green. So I'm going to solve. So for the blue, you should have gotten 36. And for this one, share a spine, make a line. So this light blue angle is going to be 36. That's not 36. Hang on just a second. Yes, it is 36. Then we do 115 minus 180. You should have gotten 65 here. Your check is to take all three of these angles and add them up to 180. That's your double check. So we have a 65, 36, 79. We add them up. This is going to be 20. That's 8, 9, 10, 11, plus 7, 180. There's your check.